Okay, so 3.3 is about complex numbers. So complex numbers are a mixture of real numbers and imaginary numbers. So remember how we've been doing the domain and we've always been saying, oh, the domain is all real numbers? If you were like me, at one point I was thinking, okay, why do we have to say it's all real numbers if it's just all the numbers? Well, there's a set of imaginary numbers, and we're going to talk about that today. Okay, so we're going to perform operations with pure imaginary numbers, and a pure imaginary number has a certain form, and then a complex number has a certain form. So the form of a complex number is A plus BI. Okay, A is the real number, and then the BI is the imaginary. So when it says pure imaginary numbers, the form of that is just BI. There's no real number there. Okay, but I think it's helpful to know the complex is A plus B. That's where it comes from, and that's why it's just the B in front of the I. Okay, and then this section is a no calculator section. So make sure when you're practicing that you aren't using your calculator. You can use it to check, but your next quiz is going to be part calculator, part no calculator. So we definitely want to practice how we're going to be assessed, okay? All right, so let's start with the definition of imaginary numbers. So DEFN, that's the definition, okay? So an imaginary number is the square root of a negative number represented by I. The square root of a regular number represented by I. Okay, and so I is defined as the square root of -1. Okay, and I squared is defined as -1. We're going to put a box around this because this is what we're going to be using the most today. Okay, so let's think about why that happens. Well, if it's I squared, okay, we know that I squared is equal to the square root of -1 squared. You plug that in. You guys know what the relationship is between the square and the square root? Yeah, they're the inverse. Yep. Anytime they're inverses, that's why they cancel. They undo that operation. Okay? So that's how we're able to simplify that as I squared is -1. We're going to do some other simplifications today, such as I to the third. So I to the third power, we're going to rewrite, and the I is a fancy I, like an italicized I, so when you're writing it, if you could put that in your work as well. Okay, I to the third power, we're going to rewrite using the properties of exponents. So you may remember when you're multiplying two values with the same base, their exponents are added together. So if you can't see the exponent, do you guys remember what it is? A 1 to the first power. Yep, so 1 plus 2 is the 3. Now the reason why we would rewrite it like that is because we just talked about I squared is -1. Okay, so we're just going to substitute in -1 for I squared. And then you're going to have -9. Okay, so we are often going to simplify using the I squared. Okay, so if you have I to the fourth, that's the same thing as I squared times I squared. Okay, so what can we plug in for I squared here? Yep, so this is just going to be -1 times -1, and what does that simplify to? 1. Okay, and we are going to do more of that in a little bit. Okay, so we're going to be doing a lot of simplifying today, and the directions just say to simplify. Simplify means so many different things. So the first thing we're going to work on is simplifying radicals. Okay, we're going to simplify radicals. Okay, and that means you can have no perfect squares under the radical. Okay, so the perfect squares are any number that is raised to the power of 2. We will talk about that in a little bit. Another thing that we're going to use is this rule. Okay, so the rule is if you have the square root of a times b, you can break that up into the square root of a times the square root of b. If a is positive or if b is positive. Okay, they both don't have to be positive because we are going to be doing some simplifying with that, but you can't have two negatives and make it a positive. Okay, so it doesn't work if a and b are both negative. Okay, so you can't use that if a and b are both negative. We're going to use something else for that. Okay, so we're going to start off by doing the square root of negative 16. So you can rewrite this as the square root of negative 1 times the square root of 16. Okay, we know that according to our definition, the square root of negative 1 is I, and we know that the square root of 16 is what? 4. So if it's I times 4, we write it as 4I. Okay, so anytime you have a negative underneath the radical, you're going to have an I in that. Okay, now 16 was a perfect square. We're going to do one that is not a perfect square. We're going to do the square root of negative 96. So we're going to start in a very similar fashion that we did to the last one. You do not have to write out this step every time, the square root of negative 1, because that's just going to turn into what? The I, so this is going to be I square root of 96. Okay, what we are going to do is we're going to factor tree it. So when you're doing a factor tree, you're really doing what's called the prime factorization. You know what it's called, prime factorization? Okay, so it's prime numbers. So we're trying to simplify that with very simple prime numbers. Okay, so what's a very simple prime number that goes into 96? Yep, you can use 3 or you can use 2. So either one is fine. Okay, if you're doing this without a calculator, I want you to pick whatever one is easiest for you to do. So for me, it's easier for me to cut these in half. So I'm gonna, anytime it's even, I'm gonna cut it in half. Okay, if you're having trouble cutting 96 in half in your head, just split it up into numbers that you're really familiar with, like 90. Half of 90 is 45. Half of 6 is 3. 45 plus 3 is 48. Okay, so what we're doing is we're rewriting this as multiplication. So 2 times 48 is 96. Okay, so then we're going to break down 48. 48 is 2 times what? 24. And then 24 is 2 times 12. So you just keep going until all you have are prime numbers. Okay, so for this one above, we did the square root of 16, okay, and the square root of 16 is 4. Do you guys know why the square root of 16 is 4? Okay, and so if 4 squared is 16, and you do the square root, we talked about earlier, the square root undoes the power of 2, right? So in order for something to come out, you have to have how many of them? 2. So anytime there's a group of 2, that's going to go on the outside. Okay, so I have 2 2s, so 2 goes on the outside. Do I have another group of 2s? Yeah. So that's going to go on the outside and get multiplied together. And then if you don't have a group of 2, that has to stay on the inside. See how we still have this I out here? So I'm going to put the I with it on the outside. And then what's left inside is the 2 times the 3. Okay, so then from there you can multiply. 2 times 2 is 4. 2 times 3 is 6. This is going to be your final answer. Okay, now some of you might be really good at your multiplication facts, or you might be able to pick out a perfect square. Do you guys know what the biggest perfect square is in 96? No. You guys can figure it out backwards, right? Because if 4 is on the outside, yeah, so this is going to be 16 times 6. So if you knew that 16 times 6 was 96, you could also just set it up this way, where you're writing out the perfect square, right? So again, you get 4i root 6. So you can choose what method. When the numbers get bigger, the factor tree really is the way to go. But if you have a smaller number, like the square root of 12, what's the perfect square in 12? Yeah, so it's just root 4 times root 3. So it would be 2 root 3. So something like that, it may be simpler for you to find the perfect square. Do some of you remember doing it like this in geometry? Oh, in algebra? Okay. Did you do that? Did you do one of these in geometry though too?
I just remember we had a whole guy who gave glasses.
Oh, that sounds so fun. All right, good. Okay, so for C, you have the square root of negative 24 times the square root of negative 2. So remember what I told you earlier. You can't use this rule if you have one of those, if both of these two numbers are negative, so your A and B. Okay, so you can't just multiply those together. You have to make sure that you're acknowledging that you have imaginary terms. So what we're going to do is we're going to write this as I root 24 times I root 2. Once you've put the imaginary numbers there, now you can start to simplify. And when you're simplifying with radicals, you can multiply the numbers on the outside. So you can multiply I times I, which is just like if you had x times x. What's x times x? X squared. So this is going to be I squared. And then you can also multiply what's inside the square root. So 24 times 2 will be 48. Okay, and then again, some of you might already know what your value is going to be, like what your perfect square value is. But if you need to do a factor tree, we can do that as well. Okay, so if you have 48, again, anytime it's even, I cut it in half because that's easy to do in your head, right? So you have the 2 and 24, and then you're always just trying to find prime numbers that go into that value until you can't find any more prime numbers. So what you have is a list of numbers that when you multiply them together equal 48. Okay, so anytime there's a group of 2, it comes out. So here's one group of 2. Here's 2 groups of 2. So what number is going to be coming out there? 4. And then what's left inside? The 3. Okay, so you can do it that way. You can also find your biggest perfect square. Yep, so it would be root 16 times what? Times 3. Okay, and then instead of I squared, what are you going to plug in for I squared? Negative 1. What's the square root of 16? 4. Okay, so either way that you get that, you should have negative 4 root 3. Okay, from here, it would be the 2 times 2 to get the 4, and then the 3 would be left inside. Okay, so I know that was a lot of review with some new stuff. What questions can we think of?
What is this I?
You mean on the outside?
Yeah.
That's what we're going to do some work with that next. So, like if you had 3 of them, you could get I cubed. So, the next thing we're going to do is we're going to simplify with i's. Okay? So, if you have I to the 32nd, okay, and you'll use the same technique. Okay? If you have I to the 32nd or I to any power, your goal is always to rewrite in terms of I squared. So will you guys write that down for me? You're always going to rewrite in terms of I squared. So we actually did that a little bit above, right? So remember you're asking about I cubed. It really is just going to be this process where you do the I squared times I. And just see what was left in front.
I was just wondering because, I squared in front of the 4, so
Yep.
third time that.
Yep, sometimes you'll have the I out there. So
I
if
was thinking I to the power of 4, so would
you are going to be able to substitute. So no matter what you have, you're going to try to rewrite it with I squared and substitute in that negative 1. And then you're either going to be left with a number or something with I. Okay? So when you're rewriting in terms of I squared, we're going to use another one of our patterns. And this is the product property. So if you have 2, so up here with me, okay, if you have I squared, what you have to ask yourself is how many times does 2 go into 32? 16 times. So you can rewrite this as I squared to the 16th because 2 times 16 is 32. Okay, and then you're going to substitute in negative 1. And then from here, you have to know your exponent rules. So if you have a negative 1 to the power of 16, do you guys know what your result's going to be? Yep, it's positive because you have a negative number, but it's raised to an even amount. Good. If it was, what if it, instead of 16, what if it was 15? Then we have to be a negative. So we have to know any negative raised to an even number is going to result in a positive, and any negative raised to an odd power is going to result in a negative. Okay, so that's something that you'll be working on. All right, and then let's try a different type of example. So you might see something like this. We have negative 6i, 2i, negative 5i. Okay, and then I want you to think about what you want to do first. And then, so what do you guys feeling like you do first here? Multiply. Okay, so if you're multiplying, we can multiply all the numbers together first. So I would do like negative 6 and negative 5 because that's a what? 30. And 30 times 2. Yeah, okay. So after you multiply the numbers, you're going to multiply the i's. So I times I times I cubed. Okay, so then just like we did before, we're always trying to rewrite this in terms of I squared. because if it's in terms of I squared, then we can plug in -1. So this is the same thing as 60 times I squared times I. Again, this is the same property that we just did in our box above here, right? So we do that so you can plug in -1, and I'm fine if you just plug in the -1 below. Okay, so then your final answer is going to be -60I. All right, you guys want to try the next one on your own first? You want to see it first and then decide? So I want you to follow your order of operations. Okay, so with your order of operations, what do you have to do first? Parentheses. Yep, and then there's nothing to simplify in the parentheses, so we go to, yep, the exponent. So when you're doing the exponent, remember that -7I is the same thing as -7I multiplied by itself. Okay, so I'm going to keep the -4I in front. -7 times -7, 49, I times I squared. Okay, and then from here, again, you're going to multiply the numbers together. So if you're doing -4 times 49 without a calculator, what are some strategies you guys would use?
4 times 9.
Okay, so 4 times 40 and 4 times 9. So 4 times 40 is 160, 4 times 9. Okay, and then what's another method? Yep, just make sure you do the 40 and then put the 0 on there. Yep.
4 times.
Yeah, that was the other way I was thinking too. If you do 4 times 50, you know that that's 200, and then you can just subtract 4 because it's 1 unit away from it. Okay, so either one of those are going to work. Okay, and then you have -196 because you have the positive times the negative. And then instead of multiplying those together, do you guys see how you already have the I squared? So you have to break it down into the I squared anyway, so I would just keep that and substitute in the -1 here so that when you do the negative times the negative, you can rewrite it as a positive. You could also even plug it in there if you wanted, right? Do 49 times -1, then multiply that. Okay, so the order that you do that in isn't going to matter because you're multiplying them all together. Okay, so for example 3, we are going to solve each equation. Whenever you are solving, okay, you are going to be finding your value of x. And there's one key thing we're going to have to remember. Let's see if we remember it. Okay, so you're trying to get x by itself, right? I'll give you a minute to start that. And then okay, so we're trying to isolate x, get x by itself. Okay, and then Zilla, what did you do first when you were solving for this? Good. So we're moving this over. Your equal sign gives you 2x squared equals -288. All right, and then Berkeley, what do we do after that? Divide by 2. What'd you get? Awesome. Okay, and then Z, what'd you do at this step? Yep, so to undo the power of 2, we're going to take the square root. Okay, and then whenever you take the square root, you have to remember to put what? What do you need? Or did you guys stop here, or did we do something? Yep, we are going to do that. You also need your plus or minus when you're solving. That is something that people sometimes forget when it comes to the test, so let's make a little note. So you need your plus or minus when solving. And that's because you have x squared, right? You're taking the square root, so you don't know if it's the positive or if it's the negative. Okay, but yep, we're gonna take the I out so that it's the square root of 144, and we know the square root of 144 is, yep, so it's just gonna be plus or minus 12i. Okay, so don't forget the plus or minus. That's a simple thing that sometimes people forget. All right, so I want you to give this one a go. See if you can solve the whole thing. So simplifying everything. Yep. Okay, Zarish, can you tell me your first couple steps here? All right, and then what did you do? Nice, what'd you get when you divided? Great. Okay, and then it looks like most of you made it to this step where you have the plus or minus I root 50. Okay, but now we have to simplify. Okay, so you can either do the factor tree, or some of you might recognize the perfect square. What's perfect square? It goes in 25. Okay, so when you are doing that, okay, this is the square root of 25 times the square root of 2. All right, so Logan, what's the square root of 25? 5, so it's going to be 5i. What's in the square root? Good. You got it. All right. Questions on that? All right, let's do the simplifying. So, oh, it's asking us to simplify again. So when you are simplifying, it is going to cover every single operation. We are going to add, we are going to subtract, we are going to multiply, we are going to divide. So if it's asking you to add, you're going to add like terms, and then you have to put this in the form a plus bi. Okay, and then all you have to do is add or subtract like terms. Okay, so then here, your like terms are going to be the real numbers and the imaginary numbers. So you have 4 plus negative 6. What's that going to be? Negative 2. And then you have 2i minus 7i. Great. So you're just going to put the real number value first. Okay? So always put it in this form, a plus bi. when you are subtracting, you have to be a little more careful. Okay, so one thing I like to do if I'm subtracting is I will distribute the negative. Some of you guys are really good at doing that in your head, like the 1 minus the negative 2. What happens when you minus a negative? It becomes a positive. So it's a positive 2 and then a minus 3i. Okay, I like to distribute mine and then combine my like terms. I just find I make less simple mistakes that way. So 1 and a positive 2 is going to be 3. And then how many i's am I going to have? Negative 6, right? So negative 3i minus 3i is negative 6i. Okay, so not 0, which sometimes if we look at those, we can think that they cancel. Okay, great. So that's addition, that's subtraction. Let's do some multiplication. Okay, and then when you are multiplying, if you have two binomials, you're going to use FOIL. Okay, we're going to use FOIL, and then we are still looking for opportunities where we are going to plug in I squared. And we're going to substitute negative 1 for the I squared. Okay, so anytime you have I squared, you're going to do that substitution. Okay, so when I'm doing the FOIL, I always start with the first. 3 times 4 is 12. And then I think I showed you, like, I like doing this little nose here to do the inside. And I like doing this mouth, the 3 times negative I, to do the outside. Yeah, and then, so one reason I like to do it in this form is so that I can just go straight down, because 24 minus 3 is 21, so I have the 21i. So I like doing that instead of writing it out horizontally. You can choose whichever way you want to do it. And then 6i times negative I is going to be negative 6i squared. So yep, you're going to plug in the negative 1 for the I squared. Negative 6 times negative 1 is a positive 6. Okay, so can you guys write your final answer in the form A plus BI? All right, and then Brendan, let me know what you got when you got it. Great. Okay, and then make sure you guys put it in that A plus BI form too. Good job. All right, and then for part D, we are going to FOIL again, but you should notice something special happening in this one. Okay, so go ahead and FOIL that. Okay, so when you FOIL, you're going to start with 2 times 2 to get 4. You have the positive 18i and the negative 18i. And then make sure when you do the positive times the negative, you do write this as a negative. Okay, and then you should have 4 minus 81 I squared. You plug in the -1 here, so then it becomes addition. Okay, so your final answer is just a number. It's just going to be 85. All right, now what we can do is we can apply what we've just learned to a story problem about electricity. And in electricity, the J acts as an I value. Okay, so we're going to use J for this, but anytime you have J squared, you are going to plug in a -1. Okay, so it says the voltage V of an AC circuit can be found using the formula V equals CI. They tell you C is the current, I is the impedance, and then they give you values for each one. So if C is 3 plus 2J, and if I is 7 minus 5J, this is in amps, this is in ohms, then you need to determine the voltage. So we're going to be determining the value of V. Okay, so your equation, the voltage is equal to C times I. We're going to plug in 3 plus 2J for C. We're going to plug in 7 minus 5J for I. Okay, and then I'm going to let you go ahead and FOIL. And then again, make sure that you write your answer in A plus BI form. Okay? Okay, and then so you should have 21 plus 14J minus 15J minus 10J squared when you FOIL. And it looks like most of us are doing a really nice job with that. And then when you plug in your negative, this becomes a positive 10. Okay, so your like terms are 21 and 10. That gives you 31. What is 14J minus 15J? Negative J or -1J. And then we're determining the voltage, so this is going to be in volts. And that's your final answer. Okay, you guys remember doing the FOIL from algebra pretty strongly? All right, then the last thing we have to do, we did addition, we did subtraction, we did multiplication. Now, we do division. So, you have -2 over 5 minus 8I. Okay, and when you are dividing, this is, notice it says simplify, we are going to do more of a simplification here. So when you have I in the denominator, we have to simplify by removing it from the denominator, because you guys might remember rationalizing the denominator last year or the year before. You guys remember if you had a square root in the bottom, they said, no, you can't have that, and you had to multiply by something? Is that ringing any bells? Okay. So I is the square root, so that's why we don't want it in the denominator. So to simplify, you are going to multiply by the conjugate of the denominator. Okay, so that's a special word, the conjugate. I'm going to talk to you about what that means. again, you want to get rid of the I. So if you're getting rid of your I value, you want it to just be a number. Remember earlier, we did this and we just got the number 85. These two values are conjugates. You see how they're the same number, but you have the opposite? Okay, so what you're going to do is you're going to multiply by the conjugate, and the middle number is going to become the opposite. So it's 5 plus 8i. Okay, so the conjugate is going to be the same values, but now we're going to multiply by the positive. Okay, so we have two things that we're doing here. We're multiplying on the top and we're multiplying on the bottom. You have to do that because if you multiply by the same thing on the top and the bottom, what are you really just multiplying by? 1. So if you're multiplying something by 1, you get the same thing. All right, so let's FOIL. And the inside I have negative 40i. On the outside I have 40i. So are those going to add to make 0? Yes. So let's do the bottom together first. So 5 times 5 is 25. We just saw that those two canceled out. Negative 8 times 8 is negative 64i squared. And we're just going to simplify all of the bottom together right now, okay? So if you plug in your negative 1, and I'm fine with you just showing it in this step. You don't have to write out the whole step again for that. And then we're going to add those together to get 89. Okay, and now we're going to simplify the top. So you don't have to FOIL on the top because you only have one term here. What are we going to use? What operation? Property? Distributive. Yep, you're going to distribute negative 2 to 5 and negative 2 to 8i. You don't have any like terms to combine, okay? So the last thing that you're going to have to do is you're going to have to put this in the form a plus bi. So to do that, to put it in that form, all you have to do is divide each of these, and sometimes you'll be able to reduce and sometimes you won't. Okay, so the A term is the real number. The B should be in front of the imaginary. And it should be in simplest form. Okay, so if there's no number that goes into both the numerator and denominator, it's in simplest form. Okay, and you won't have your calculator, so you aren't going to write it as a decimal. All right, for the next one, I want you to write what you think is the conjugate is going to be, okay? So write what you think you're going to multiply by on the top and the bottom. Okay, so I'll give you a few seconds to do that, and then we'll talk about it. Okay, so before you start multiplying, let's make sure you're going to multiply by something good. So, I saw that you guys either chose this or you chose this. Okay? When you are multiplying, you want these two numbers to be the same. So see how the 5 and the 5 are both the same? So if this is negative 4, we're going to multiply by negative 4. The only thing that's going to change is that number in the middle. Okay, so that's why I wanted to make sure we went over one like this. Okay, so that you know the conjugate has the first number the same. The only thing that changes is that middle value. Okay, and then again, we're going to FOIL on the bottom. So when you're doing this, negative times a negative is going to be a positive. You can just do this check in your head, the negative 12 and then the positive 12. And then a positive times a negative is a negative. And then, of course, we're going to be plugging in that negative 1 for I squared. So this becomes 16 plus 9. What's 16 plus 9? 25. Okay, in the numerator, we're going to distribute again. So 2i times negative 4 is negative 8i. 2i times negative 3i, I do the 2 times negative 3, and then the I times the I. Okay, and then you only plug in negative 1 for I squared. So when you're simplifying this, remember that the a plus bi form has the real number go first. So a negative 6 times negative 1 is a positive 6, so I'm going to write that first. And then the negative 8i is going to go behind it. And then you can just go ahead and split this up as 6 over 25 minus 8 over 25. Okay, nothing to reduce there, so that's going to be your final answer. Yep, what questions do you guys have for me on that? Sure? Okay, and then the last one we're going to do, you can see that one looks a little different. Oh, yep, so it's in that form, A plus BI. So the number term will go first. Yep. So we're always going to write it in that form, that A plus BI form, where the real number goes first, the imaginary one goes second. Okay, now there are actually multiple ways to do this one, okay, but a lot of you can do this based on instinct. What do you guys want to multiply by? Negative 5i, yep. Okay, so even if it's not a binomial, you can just multiply by the opposite value, so 5i and negative 5i plus u. Okay, so that means you're going to have negative 25i squared, and then the negative times a negative is going to be a positive. All right, and then we'll distribute on the top. So negative 5i times 3 is negative 15i. Negative 5 times 10 is negative 50i squared. And then whenever you plug in that negative, a negative times a negative is a positive. What I'm saying out loud to you is exactly what I say in my head when I'm doing this. Okay, that can really help cut down on some of those smaller mistakes. And then you always want to write this, so it's in A plus BI form, and you always want to check to see if you can reduce or simplify. Okay, so you have to make sure if you have a fraction that you reduce and that you put it in the simplest form. Okay, so 50 over 25. Well, what's 50 divided by 25? 2. What goes into both 5 and 25? Okay, so if I divide by 5, 3/5, and then I have my I with it. So this is going to be your final answer. Okay, so always reduce fractions, always put that in your simplest form, okay? All right, and then this is your homework for 3-3. We are going to start reviewing tomorrow. I highly recommend doing this section because there's a lot of new problems mixed with some review that we may need some practice on.